Hello everyone, I'm Eno Zhang. I'm a second-year PhD student in University of Southern California, majoring in computer science. Today, I will give you a presentation on our ICEIS paper on events recommendation in social networks with linked data enablement. In recent years, social networking services become more and more popular. They allow users to share their findings and explore the world in a very convenient way. Event is a very critical component in social networks. People can create and share events in social networks and then join events with their friends. However, there are so many events in social networks, so it's hard for a user to find the right events to join. As a result, event recommendation is needed for making event discovery easier. On Facebook, events recommendation has already been enabled. However, the recommendation method is mainly based on location information. For example, I have been to Stable Center before, so the recommender mainly lists the events which will be held in Stable Center. The intuition of our approach is to find the semantic meanings of users and events, and then we recommend events sharing similar semantic meanings to different users. And specifically, we use LDA techniques. So in traditional LDA, there is a concept of documents and words. So the output is kind of topic distribution over documents, and this topic distribution is calculated based on the words the document contains. And in our application, we model event and user as document, and we also extract the profile keywords for event and user, and consider those keywords as the words here. And then we calculate the topic distribution over each event and each user. So here is an example. We have two events and one user, and the first event is more related to music, and the second event is more related to sports. So this vector is kind of like the topic distribution over that event. And also this user has its own vector. So as we can see here, so this user is more related to sports, and this vector is generated using LDA. So based on the topic distribution vector, we proposed 4 approaches for events recommendation. The first one is similarity-based approach, SBA. And in this approach, we calculated Gaussian similarity between the topic distribution vector of one user and one event. So here is an example. We use the 2 events and 1 user we mentioned in the previous slides. So the first event is more related to music, and the second one is more related to sports. And the user has interests on sports. So once we calculate this Gaussian similarity between those 2 pairs of vectors, and then we generate the score. So as we can see here, user 1 and event 2 has larger similarity compared with the first pair. And then we recommend the events with high similarity with user to the user. So here we recommend the sports events to user. So the second method is relationship-based approach, RBA. So the intuition is that if one of my friends is attending one event and that friend shares same interests with me, then I have large probability to attend the same event. So here is an example. There are 2 more users, user 2 and user 3. So user 2 has the topic distribution vector as this, and user 3 has the vector like this. So user 2 has interests on music, and user 3 is more likely to attending sports event. And then we also know that user 2 is going to attend event 1 and user 3 is going to attend event 2. And then we calculate the user similarity between user 2 and user 1, as well as user 3 and user 1. And then we generate this relationship-based score for user 1, event 1, user 1, event 2. And then we see that the score for user 1, event 2 is higher. And then we recommend the sports event to user 1. The third approach is history-based approach, HBA. In this approach, we use logistic regression model to do the recommendation. Specifically, we use training site to learn the parameter beta, and then we calculate topic distribution for the future events, and then generate S3 score. Use this model. And here is an example. We have event 3 and event 4. So those are kind of history information. And we know that user 1 has already attended event 3 and user 1 has rejected event 4. And then we can use those two events as the training set to train the parameter beta. And later, when event 1, event 2 comes, and we generate topic distribution vector over event 1, event 2, and then derive the S3 scores based on those vectors. And here the example shows that the score for user 1 and event 2 is larger than the user 1, event 1 pair. The last approach is hybrid approach, ICEIS'13. So this approach is kind of like weighted sum of the three scores, and we assign a weight to each of the scores. And we use tenfold cross-validation to learn the weights. And specifically, there we use two types of data set. The first one is Facebook data, and the second one is academic conference recommendation. And actually, for different data sets, they have different weights. For example, in Facebook, since we have very few history information, that's why omega-3 is quite small. But for conference, we have a lot of history paper and publication information. That's why omega-3 is large. The first dataset we use in the experimental evaluation is Facebook data. Specifically, we crowd 1,088 users and 4,040 events using Facebook Graph API, and we use mean average precision as a measurement. And this figure shows the results on Facebook data. As we can see here, the x-axis is a number of topics. Actually, this is used in LDA, which generates the topic distribution vectors. And from this figure, we can see that ICEIS in general performs best, and because it's kind of hybrid approach, which outperforms three individual approaches, and the history-based approach performs worst. It is because we lack history information for those users to train the parameters in the logistic regression. As you know, the first step of our approach is to generate the topic distribution over events and users. And the input for LDA is the words in the profile for users and events. So in order to enrich those profiles, we enabled open link data in our system. Specifically, for academic application, we enrich user profiles user DBLP linked data. And in DBLP, we have the publication history of each author, and we also have the co-authorship for each author. And we also enrich event profiles using event seer linked data. In event seer linked data, as you can see here, for each event we have the subject, which is kind of like the topic information, and also the involved agent, kind of like the program community. And also we have the location information as well as time information. And for each person in event seer, we also have the topic information as well as the kind of like relationship with other authors. Here is the results for academic event recommendation with linked data enablement. And in general, all approaches outperforms the random approach here. And for the first one is the SBA, which is similarity-based approach. So as we can see here, if we have more events and more person information here, and then we can build a better LDA model to generate topic distribution, and then the recommendation precision can be better. And the second one is the relation-based approach compared with similarity-based approach. As you can see here, it seems that similarity-based approach outperforms relation-based approach. It is because the relationship in our academic events recommendation applications seems now quite clear, because it's a little bit hard to extract the co-authorship from event seer. And that's why the pure similarity approach can outperform the relationship-based approach. The last table shows that the hybrid approach can outperform each individual approach. It is because we use tenfold cross-validation to generate a good weights for each individual approach, so that the hybrid one can have better performance than the individual approaches. So here is the conclusion. So in this paper, we propose 4 approaches for event recommendation, and all those 4 approaches are based on LDA, in which the topic distribution are generated for each user and event. And the first approach is mainly use the similarity between the topic distribution of user and events and do the recommendation. And the second one is a relationship-based approach, in which we also consider the relationship between users and we calculate the similarity between users. And third approach is history-based approach. We consider the event's attendance history for each user and build the logistic regression model for each user and then do the recommendation. And the fourth one is kind of like hybrid approach, which is a weighted sum of the previous 3 individual approaches. Secondly, we enabled open link data in the event recommendation. Specifically, we enrich the profiles for user and events, and then we can build a better topic distribution vectors for users and events. As a result, the accuracy for recommendation can be improved. Lastly, we evaluate our approaches on real data sets. Specifically, we use both Facebook data and academic conference data to evaluate our approaches, and the results show that our approaches can outperform the random approach, and also the hybrid approach usually outperforms each individual approach under different settings. Thank you for attending my presentation. If you have any questions, you can email me.